This Zoom session is being brought to you by the fractal snow ring. One of my favorites, by the way. Real frosty. Okay, today I'm going to briefly go over 5.2 because it's an extra credit section. And then we'll go into more detail on 5.3, the complex plane and de Moivre's theorem. Okay, polar coordinates, and I mentioned it last time. Polar coordinates, a point is specified by the distance r out from the origin and the angle theta from the positive x-axis. Rectangular coordinates are specified by x and y, how far horizontally and how far vertically. The equations relating them go as follows. X equals r cosine theta and y equals r sine theta. This goes from polar coordinates to rectangular coordinates, p to r. There's probably, I know that on the TI calculators there is a p to r and an r to p button on the machine. Now going from rectangular to polar, r, well, because this is the right angle triangle, r equals the root of x squared plus y squared. Theta, it's a little more ambiguous. It's either arctan y over x if in the right half of the plane where x is positive, or it's pi plus arctan y over x in the left half of the plane where x is negative. All right, now we can use these identities to convert polar equations to rectangular equations and vice versa. For example, r equals a, so it's a distance a from the origin. That's r is root x squared plus y squared, so x squared plus y squared equals a squared. That's the circle, center 0 by 0 and radius a. Theta equals a for a specified angle a. Arctan is y over x equals a, so y over x equals tangent a, so y equals x tangent a. So it's this line to the origin. R equals a cosine theta. Well, if we multiply both sides by r, then r squared equals ra cosine theta. R squared is x squared plus y squared. R cosine x theta is x, so x squared plus y squared equals ax. And after a bit of transpose the ax and completing the square, we get this equation. X minus a over 2 squared plus y squared equals a over 2 all squared. This is a circle, radius a over 2, going with a center at a over 2 by 0, going to, well, actually it goes to a, but oh, I should change that in the canvas. That should be, it goes through a by 0 and 0 by 0. This is page 3, 5, 2, 3, through a over through a by 0. I'm going to change this later. Okay. Now r equals a sine theta. You go through pretty much the same thing. Get x minus x squared plus y minus a over 2 all squared equals a over 2 all squared. This is a circle with center at 0 by over 2, going through 0 by 0 and 0 by a, radius a over 2. R cosine theta equals a means x equals a, and that's a horizontal, that's a vertical line. X equals a. R sine theta equals a means y equals a, so that's a horizontal line at y equals a. If you now these others, it's getting a little more complicated. R equals a plus and minus b cosine theta. Well, what you get is one of these curves. If b is less than a, then it's kind of this circle kind of dented in. If b equals a, then it comes to a sharp point right here at the origin. B is bigger than a, then it loop-de-loops at least once around. There are a couple of negative values for r. These are all called cardioids, meaning heart-like. R equals a sine 3 theta. You get this 3-petaled rose. And again, there's this is probably the best way to actually see these is by using the polar coordinates graphing application on your graphing calculator if it has one. So we had some examples. R equals 4 is this circle. Theta equals pi over 3 is this line. R sine theta equals 4 is this line here, this horizontal line here. R cosine theta equals -2 is this vertical line here. R equals 2 cosine theta is this circle tangent to the y-axis. I equals -4 sine theta is the circle tangent to the x-axis. Oh, note it for this -4, and for many values, times where r is negative here and here, you get a negative value for r, so you plot it in the opposite direction. Whatever, we proceed. I'm going to call this a halt.